I started my career first studying at JJ for a year. After that, I went to England to pursue further. And I read that a famous architect called Frank Lloyd Wright mentioned that architect, unlike doctor, cannot bury his mistakes. That impressed me so much that I wanted to be his apprentice. So I sent him my sketches and he accepted me, and I spent about 4 years at Taliesin, that is the place his apprenticeship was called. It was two places in Wisconsin and Arizona. Another thing is, he used to tell us practically every Sunday, his lectures, that the reality of structure or anything made by man is not the shape, not the material it's made of. Like, for example, take a drinking glass. It's not the shape, it's not the material, glass, metal, wood, clay, anything. It's the idea that it holds liquid. So the idea is the reality. And so same way in architecture. The reality of any building is the idea behind it. And our job is try to convince our clients. This is the basic thing about architecture. Then, of course, depending on his budget and all that, you come out with the material to be used. But normally people think architects waste money by grandiose, normally it's material, easier to put marble and place looks good. But I would say that is frivolous. It's the space that created. And space and structure can only be, can mainly be created by steel, I would say. Larger spans are possible. So that's how I got into using of steel and convincing my clients. This, of course, happened only when our economy was enlarged from domestic to at least other economies which were globally tied to the markets. It was no more commanding the heights of the economy, which was there earlier. So the government control went, so we could import. One of the things, the building I started first, structural steel, with naturally my friend Kamal Harka, was the IFCI tower, which I won the competition on the basis that I'll be using steel to do faster and make an intelligent building. The second was, which was very successful, and that's how I entered the competition for ICICI at BKC, and there again I won that on the similar basis that I'll be using steel for faster. Look at IFCI if you want any recommendation. And again, intelligent and all other things that were coming to the market at that time. So that you can see for yourself. I got 2 towers and a bridge on the top, which is a boardroom, and also a link between the 2 towers. Third one, of course, the building was just not possible to use concrete in any case, thank God for that, was a structure near the railway lines, because whatever the distance you leave from the railway line, you can go twice the height. And of course, the maximum is 50 meters. In order to consume the FSI, I had to go around 175 meters, nearly 600 feet. So there we got columns from Japan. They were square columns, hollow. We fill them with it could be sand or mortar, and didn't need any encasement in concrete. So we used intumescent paint, and it's come out very good. It's fastest construction for considering the height and restrictions on the access. It was a SRA project, so there were a lot of restrictions, physical restrictions. People were staying next 10 feet, 20 feet away. In ICSCI, it was 8 sections we got from Trade Harvard, Luxembourg, and encased them in concrete. Then, of course, the came for Tatas, because the lease was hardly few years left, so I had to finish the building fastest. So suggested steel, 8 sections, and that's the Wellington Muse. That's also came out pretty fast. I always tried with the idea of trying something new. There was space frame being used abroad. I'm talking of 1978 or so. And I designed this Mahindra Towers, an L-shaped building with a service core in the middle, joining the 2 floors, 2 wings. So visual connection I wanted. So Kamalarka said, I will design the space frame, but we will weld it. I mean, take normal square sections and weld it. And that's what happened. And of course, now it's been replaced after so many years. It got rusted. So now you've got nodes and powder coated and all space frames. Then there was another challenging thing. I had in the Meridian Hotel in Delhi, the atrium I got is about 100 feet by 100 feet. And I wanted to be rather daring and suspend a restaurant in the atrium, welded to the steel truss. There again, Kamalaka took up the challenge and did a terrific job. Then, of course, the space frames as such, and then, of course, and then there's another hotel at the airport here in Mumbai for Lalit Suri. That time it was Continental, but later on I think it's called the Lalit only. It's got one of the largest atriums in the world, I would say, for a hotel. Probably almost same size as Hyatt Regency at O'Hare Airport in Chicago. There, of course, normal steel. We didn't have to import anything for the roof. And an Israeli company, Alumaya, they did the roof over the atrium. Then there are space frames I've used in every large spans where, like CBI headquarters and even in INS building here, I'm using a S-shaped bridge, which I had used earlier in Logitech for Shobhit Rajan. Got a central core, again 2 huge blocks. So and a S shape, so that the bridge connection from service core to the wings didn't have a bridge over the other. So S-shaped avoided all that. And it was an individual bridge, which could only be done in space frame. I always wanted to try. My first, after coming to India, my first project was Captain Pereira. He wanted a house in Uran. This is in early 60s and mid 60s. So I did a asymmetrical hyperbolic paraboloid. There was a terrific engineer like Mahendra Raj, who practices in Delhi now. Those days he used to be in Bombay. And that is the first, I believe, first hyperbolic paraboloid in India. I was trying to do something a little unusual. So it's fun, but with steel you can do so many things. That's one thing. Well, thanks for giving me the award again, and wish you steel industry all the best in the world. Thank you.